Today we have a challenge. The question is bracket open a to the power of 2 plus 1 close bracket all raised to power 2 equal to bracket open 1999 to the power of 2 plus 1 close bracket all raised to power 2. Well, that would be all the four values to a. If you look at this question, you can easily guess the two first values to this expression, which are likely to be plus 99 and minus 99. But the other two, how do we get the other two? So we have to solve this challenge based on the other two values. Okay, left with the first two values, we don't have issue with that. So yeah, we take our solution. Okay, now from this expression here, I'm going to bring in a different alphabet to represent this quantity and this quantity. So let's do some crazy substitution here. So from here we say let's put x be equal to our a to the power of 2 plus 1, and let y be equal to our 9 to the power of 2 plus 1. Okay, so with this we can now rewrite the first expression here. So rewriting the first expression, this will now thus becomes, this now implies our x to the power of 2, they're equal to our y to the power of 2. Okay, so let's move this expression or this quantity on the right hand side to the left hand side of our equation. So this gives us x to the power of 2 minus y to the power of 2 equal to 0. Look at this equation very well, this expression very well. With this, you see here, what comes to mind is difference of 2 square. Okay, remember our difference of 2 square, which says that if you have your, let's use p to the power of 2 minus q to the power of 2, this is simply p plus your q, the close bracket, bracket p minus q. We all know this, right? Okay, so this is the rule we are going to use to work on this. So if we apply this rule, then we're going to have x to the power of 2 minus y to the power of 2 is equal to x plus y close bracket, bracket x minus y close bracket, everything equal to 0. Okay, so rewriting this, we have the whole of this to give us here x plus y close bracket, bracket your x minus y equal to 0, right? Okay, now seeing this, another rule comes to mind. And what is that rule? That is the zero product rule, which says that if you have your a dot b equal to 0, then this simply means your a is equal to 0 or your b is equal to 0. I believe we are familiar with this rule again. So we want to apply this rule here. So if we apply this rule here, meaning we're going to use this to 0, equate this to 0. So if we do that, we're going to have here to be your x plus y is equal to 0, or we have our x minus y is equal to 0. Easy. Now, recall that at first we do not have x and y in this system of equation. So look at our main question. Now from here, we said let x be this and y be this. So let's go back and replace our x and y with what we have in here now. So we take the first one where we have x is equal to a to the power of 2 plus 1. So if we do that, we can now rewrite this expression we have here to be our a to the power of 2 plus y. Okay, so if we have one here, bring out our plus sign here. So plus, what is our y? Our y is 99 to the power of 2 plus 1. So we have here plus 99 to the power of 2, then plus 1. Everything equals to 0. Or the other side here, which is this part, we have here our x again, which is a to the power of 2 plus 1. Then minus, here we're having minus, so we put this one in bracket because of this minus sign. So minus our 99 to the power of 2 plus 1 close bracket. Let's also put this in bracket. Okay, all right, so let's separate these two out here now. So from here, what we have here is easy. We can add this and this together. So this gives us our a to the power of 2 plus 99 to the power of 2 plus 2. everything equal to 0. Then let's just finish up with this side first. So with this, what do we do? All we need to do here is just to find the square of 99. And we know that the square of 99 is 9,801. So we go ahead to say a to the power of 2, then plus 9,801 plus 2 equal to 0, which will return give your a to the power of 2 there plus your 9803. This is equal to 0. So all I will do here is to send this to this side of the equation. So I'm now having a to the power of 2 is equal to your minus 9803. So what do I do here? I'm going to take the square root of both sides. So if I take the square root of both sides, so have the square root of this and the square root of this. This leaves the system. So I'm now left with your a, or our a is equal to, again, immediately we introduce our square root sign, then we add our plus minus here. So we are now having plus minus the square root of minus 9803. But I want to do some crazy manipulation here now. What is that crazy manipulation? I want to eliminate this minus sign in here now. So I can as well write this as minus 1 times plus 9803. That will still give us what we have here now, right? And recall, we know that the square root of minus 1 is equal to iota. We all know this, right? Good. So I can rewrite this expression I have here to give me a is equal to plus minus the square root of 9803 iota. So from here, we now have our a1. So we have a1, the first root here is equal to plus the square root of 9,803 iota. Then a2 is equal to minus the square root of 9,803 iota. Okay, so we've gotten two roots from this side of the equation right now. So let's come to this other part, the second part of the expression, where we have your a to the power of 2 plus 1 minus x. Now, with what we have in here now, what comes to mind, let's use this minus sign to open up this bracket. So we have this to be your a to the power of 2, the plus 1 minus 9 to the power of 2. They use this minus to open this to give us minus 1. Everything equal to 0. Okay, this equal to 0, please. All right. Now we're having plus 1 and minus 1. So this leaves the system. We are now left with your a to the power of 2, then minus 9 to the power of 2 equal to 0. Again, what comes to mind is difference of 2 square. Let's look at it here. Look at our difference of 2 square, what we did here now. So we can equally apply that here. So if we apply the difference of 2 square here, we're going to have this to be your a plus 9 close bracket a minus 9 close bracket equal to 0. This now implies our a plus 9 is equal to 0, or a minus 9 equal to 0. So sending this to this side gives us a equal to minus 9, or we have a is equal to 9, which is 99. These are the first two roots I told you of, that many looking at this question, you will guess the answers to be 99 plus 99 and minus 99. Okay, so what are the answer in all from here? So let's take our answer. Therefore, our a1, we solve our a1 here already. So our a1 is equal to the square root of 9,803 iota, and a2 is equal to minus the square root of 9,803 iota. The a3 is equal to, let's take the first word is minus 99, and a4, okay, our a4 is 99. So these are the four roots to our simple exponential question, which is your bracket to be a to the power of 2 plus 1 close bracket raised to power 2 equal to bracket open 99 to the power of 2 plus 1 close bracket all raised to power 2. Okay, so this marked the end to this simple challenge, and these are the results that will satisfy this equation. And I've gone ahead to put these values into the original equation, and they all satisfy this original equation. Thanks for being there. Again, you are welcome to Math Prowess. If you're not subscribed, do it to subscribe so that you get more from us. Bye for now.